Hi, I'm Beth Wilson, one of the hosts of STEM in 30, a television program for middle school students produced at the National Air and Space Museum. Today for our Air and Space live chat, I'm really excited. We are joined by Moriba Jah, who is an associate professor at the University of Texas in Austin and a tracker of space junk. Moriba, thank you so much for joining us.
Thank you. It's great to be here.
Now, to those of you who are watching, we're going to take a lot of questions. Put your questions in the comment section. We'll get to as many of them as we can. And if you let us know where you are watching from, we'll try and give you a shout out. Let's get started today by asking Moriba, what is an astrodynamicist?
That's a fabulous question. And first and foremost, hello to everybody that's tuning in. I'm very excited to be here. And yeah, so an astrodynamicist is basically somebody who studies motion of stuff in space. So whether it's motion of planets, asteroids, satellites, space debris, anything in space, kind of what causes that motion and where are things going to go at some point in the future.
Now, as an astrodynamicist, you are working on two really exciting projects. Do you want to tell us a little bit about the Astro Graph and the other project you all are working on?
Yeah, so one of the things that I noticed when I started working for the Air Force Research Lab a long, long time ago is that there's all this stuff in space. And we keep on launching more of these things. Most of the stuff that we launch, they don't come back. They kind of stay up there kind of forever. And very, similarly to how we have stuff in the ocean with plastics and stuff like that just caught up in different currents, we have objects in space that are human-made that are also caught in kind of these sorts of currents. And so one project is called Astro Graph, and it was initially funded by the Federal Aviation Administration to see if we could come up with a way that could crowdsource information about stuff in space and represent it in a common framework so that people could kind of get an idea of what's up there, who does it belong to, how is it behaving. And so that's the first project that we're going to kind of go a little bit deeper into. And then the second thing is talking about all this stuff in space. Our night sky has been changing as a result of having more and more of these objects. And if you live in a place that has dark enough skies, you definitely know what it is that I'm talking about. And so one of the impacts are to ground-based astronomers who have telescopes and they're trying to look at very remote and far off places in our universe, and they need to gather dim signals, basically the light that's coming from these places. They're looking for things that are very, very dim. And when they have these human-made objects going in front of their telescopes, that tends to be problematic. And so one of the second projects that we've been pulled into is, can we develop some sort of application that, given somebody's location anywhere on the surface of the planet, can predict over a night how much of that clutter is going to impede possible astronomical observations.
Now, we are going to pull up Astro Graph, and do you want to talk us through a couple of applications we can do on this?
Yeah, so the ultimate goal of this thing, like I said, is a way to kind of be the equivalent of like that Waze traffic map, like a Waze for space. And as Waze is a participatory sensing network where if you have Waze, you can say, oh, I'm going to punch in that there is an accident on the side of the road and these sorts of things. Can regular citizens that maybe have telescopes in their backyards and that sort of stuff contribute to Astro Graph? Now you might say, well, all right, who cares, and why do I want different opinions to come together? So that's what we're going to talk about. So in Astro Graph right now, if you go to this Astro Graph and you open it up, there's a little button kind of on the side that says debris and rocket bodies, and if you hit that, just so that you can get all the objects, you're going to see this combined set of dots. The first thing that I want to say is that the dots are not to scale. So the dots don't represent the actual size of the object. They only represent location of people's opinions of where these things are located, right? And if you kind of zoom out a little bit, interestingly enough, you might say, okay, well, so there's all this stuff. Why does it make a difference in terms of who might be supplying information? So to get to that point, one of the most dominant sources of information comes from our own Department of Defense, specifically United States Space Command. And there's like a website called spacetrack.org that you could sign up and get the information. And so if you just, from sources of information, there's a pull down menu, if you just click on US Spacecom, that is the public opinions of US Space Command in terms of all this stuff in space. Now, you can kind of see different orbits where these things are located, but if you all of a sudden from US Spacecom, if you go to the Russian set of opinions, which is the JSC Vimpel catalog, and click on that, you're going to see all these pink dots. And guess what? The pictures look very different between US Spacecom's opinions and the Russians' opinions. So you might say, well, who's right? Who's wrong? Like, they're very different pictures. And so this is part of the importance of trying to combine all of these sources of information together. One of the things that I tell my students is, if you want to understand something, you have to be able to predict it. And if you want to know something, you have to measure it. And so measurements are really the foundation to our knowledge. And if we can't combine all these measurements, we're really hindering our ability to know what's going on in space. Now, to give you an even further example of where things might not be so consistent, we're going to look at just one object and say, okay, for one object, how many opinions do we have? So if we go back to all sources for Astro Graph again, and just type in the name of a satellite is going to be Flock 1C10. If you just type in Flock, it should show up as the first option. This satellite belongs to a company called Planet, and they have many CubeSats in low Earth orbit that are observing the entire Earth, once every 24 hours. And if you just click on Flock 1C10, you're going to see where that supposed satellite is located. And on the bottom left, there should be like this bezel that has like rewind, fast forward, and pause. Because everything has this kind of simplified motion model to make things move, if you just pause that, zoom into where it says Flock 1C10 is. And interestingly enough, as you zoom in closer and closer and closer, you should see something interesting happen. You should see all of a sudden kind of a scatter of, now there's 4 dots. 4 dots represent Flock 1C10. Number 1 is where US Space Command predicts this thing is going to be. Number 2 is where the owner of the satellite, Planet, thinks it is. Number 3 is where this commercial radar company, Leo Labs, believes it is. And number 4 is where my team believes it is by processing some of Leo Labs' radar data. And interestingly enough, these things aren't lined up on top of each other. The spread between these things is probably several hundred meters, several football fields. But the thing is that if we tell somebody, you know what, you might want to move out of the way because we predict this thing might collide with you in a few hours or tomorrow, which one of the 4 dots do you believe? And that's part of the issue, is that we don't necessarily have consistency in the opinions about where things in space are located. So anyway, I just wanted to describe a little bit about what Astro Graph is and give you kind of a soundtrack about what are the different things that you might see in Astro Graph.
We have a lot of people watching. We've got some questions coming in, but I will remind everybody, put those questions in the comment section. We have Charlie and Teddy watching from Plymouth, Michigan. We have people in the Netherlands watching, Katy, Texas, Liverpool, England, that's a new one, New York, Elizabethtown, Kentucky, Clarksville, Tennessee, John in Timbuktu. So we've got a lot of people watching, and let's get to some of these questions. Why do you never see space junk in the background of pictures taken on the International Space Station?
Yeah, so I'll put it this way. I'm not going to say that you never see them. Space is still a rather big place. Again, like you see all these dots, the dots aren't to scale. So if you really like put the actual size of the dot being the size of the object, you probably wouldn't see much. That said, I will say this. I have friends that are astronauts. Some of my best friends are astronauts, and one in particular, Susan Helms, retired general. She told me a story once about going, every time she'd go into the most forward facing module of the space station, she could actually hear things dinging on the hull. Ding, 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 these sorts of things. And those are small particles of stuff. Some of it from human-based remnants, space debris. Some of it might be micrometeoroids. The point is that these objects are up there and they interact even with human spaceflight. And in fact, in the news, I think it came up yesterday that the International Space Station had to maneuver out of the way of a piece of debris. And that just happened like yesterday or the day before yesterday. So even though when you take pictures from the space station, you may not just see all this garbage cluttering it up, you can still hear it, and you still have to move out of the way. And so this is an issue.
Now, even very small pieces of space junk can do a lot of damage. Can you tell us why that happens?
Yeah, absolutely. So, just like a bullet is very small, but because of its speed, has kinetic energy and it can produce a lot of damage with whatever it interacts with. Very similarly with even specks of paint. Specks of paint traveling at very high speeds, 7 times, 11 times, 14 times the speed of a bullet, hitting a satellite. A speck of paint may not make it blow up, maybe, but it can certainly perforate some of the surfaces. It can damage it. It might be able to render it useless depending on what parts of the satellite it flies through. And these are things that we can't track, unfortunately. They're just too small for us to track. So we know that whenever we go into space, there are kind of these random bullets flying everywhere that we can't track and we can't predict. So we have to find a way to try to shield ourselves. What's the armor that we need to equip humans and satellites with to try to withstand some of these kind of random interactions?
And again, we've got a lot of people watching: New Hampshire, Colorado, Rome, Italy, Montana, Bedford, Indiana, Florida, Albuquerque. So keep those questions coming. And I want to thank whoever likes my cat astronaut in the background. I always try and have that up during these. Somebody wants to know about the Kessler syndrome. Can you tell us what the Kessler syndrome is?
Yeah, so there's this gentleman. His name's Don Kessler, and he worked, for NASA for many years. And I guess in general, the way to think about the Kessler syndrome is it's this hypothesis that at some point in time, you have so many things up in orbit that the carrying capacity of the orbit becomes saturated. And when I say carrying capacity, I want to equate that to ecological sustainability. Just like an ecosystem has a capacity of it can handle so many living organisms before bad things start to happen. Same thing kind of in space. It's a finite resource. There's a carrying capacity to orbits. And the hypothesis is when that saturates, even if you don't launch anything else, things will start bumping into each other. And, things aren't made out of rubber. And so whenever two things collide with each other in space, they tend to create more objects. And so what the Kessler syndrome is really trying to hypothesize is that even if we don't launch anything, at some point, the population will grow on its own because of these interactions and collisions amongst each other. And we are, a lot of people actually believe that we're past that tipping point, that the Kessler syndrome is kind of in effect. Me personally, I believe that nature tends to achieve equilibrium when left alone. So at some point, these interactions would become more minimal or would be like too small of a piece to really do anything. So I think that eventually equilibrium would be reached. But at the end of the day, it's still, for lack of a better term, a filth that we actually have to know how to operate in.
A lot of people would like to know, how large of an object can you actually track?
That is a question that is very, very good. I would say in general, you're really looking at the size of like my coffee mug, if it can show up here. So yeah, basically like the size of a cell phone. That's really about the limiting size that is considered trackable. So softball size, coffee mug size, all the way up clearly to the space station and school bus size things. But smaller than the cell phone or the coffee mug, it becomes extremely difficult.
Okay. Someone would like to know if could you collect this junk and send it maybe to the moon or Mars to be used there? Is there any way that this space junk can be a benefit to the space program?
I think that's an excellent question. Um, there are companies that are actually looking at a business model of recycling. So I think recycling stuff in space makes a lot of sense. Sending it to the moon or Mars, look, things take energy, and it's a lot of energy just to put stuff in orbit. That's why most of the stuff, once it dies, it kind of stays there. It costs a lot of energy to bring the stuff back, and certainly to send it to the moon or even to the sun or whatever, right? Mars, or because people say, oh well, just send it to the sun so it can like burn up or whatever. We are we are traveling. Everything in space is in a state of free fall right now. We on the planet, we are falling towards the sun, but the reason why we miss the sun is because we have this kind of tangential or horizontal speed that's so fast that keeps us from missing. Thank goodness, right? Because or else we wouldn't be doing this. um but the relative speed that we are traveling with respect to the sun is about 29 times the speed of a bullet, like 29 kilometers per second. Okay. In order for something to like hit the sun, you actually have to slow this thing down by like 29 times. If you just removed all that speed, it would just drop and hit the sun. So it takes a lot of energy to get something to hit the sun. It's not easy. And so it's not an economically feasible thing to try to do that sort of stuff.
We have a 12-year-old in Wisconsin. Now, stick with me here, who wants to know how much firework pollution is there. And if we could talk a little bit about how pollution on the earth and environments on the earth and the pollution in space and how that's all connected.
Yeah, so what I'll say is this. I'll say that as a species, there's certain behavioral patterns that we have, especially given businesses and markets and these sorts of things. And in general, environmental protection tends to be one of the last things that we think about in general. We see it with oceans, atmosphere, and climate. We see plastics in the ocean, and we seem to be discovering more and more things about marine debris. Legislation to protect this tends to be, again, on the slower side of things. And right now, space is where oceans were about 60 years ago. So the things that people were learning about ocean pollution 60 years ago are things that we're just now starting to learn about space. It would be nice if we could take lessons learned from ocean debris and say, here's all the stuff that we learned and the ways that we know we need to behave to try to reverse this stuff with the oceans. Let's just apply this to space as much as possible so that we can prevent near Earth space from suffering the same ills that marine environments have been suffering. And I want to say that for me, the connective tissue with all these environments, I believe in the butterfly effect that everything is one common fabric, and near space is not mutually exclusive from stuff on the ground. I will say that I stumbled on this thing called traditional ecological knowledge, which is the knowledge that indigenous people have in how to achieve sustainability. And I think that the link between all these things is looking at the voices of these indigenous people, like the Inuit, like Aborigines, like the Maori in New Zealand, and saying these principles about how we should behave and develop best practices and norms of behavior, and look at this in terms of custodianship and stewardship, not ownership. These sorts of things will get us to achieve sustainability.
Well, on that, a lot of people are asking, about restrictions on launching satellites, mentioning that SpaceX has just launched a ton of them. And I understand that that is causing some astronomers a bit of a headache. Do you want to talk a little bit about that?
Yeah, so this was like the second thing that I said that we were working on, that I think there's a video somewhere of it. And what we've done is this, right? It's like Elon Musk has gotten permission to launch this Starlink constellation that will allegedly deliver global internet. Okay, that's a big deal. Let's look at kind of the what possible benefits of the constellation might be. Right now, here in the United States, internet is almost ubiquitous. Like anywhere I go, I pull up, I can get stuff on the internet. There's information and knowledge that is very accessible to me. Most people don't realize that probably half of the human population has no access to internet. That's a lot of people that don't have access to internet. One of the things that I learned when I was in school, I remember sitting in a classroom in physics, and there was some point in my physics class that I realized that I could predict the outcome of the way I threw a rock or did this or that without somebody having to hold my hand. Knowledge was empowering to me. I'd love for knowledge to empower everybody on the planet. Internet could help with that. That said, it's going to take a lot of satellites to deliver this capability. And for those that, again, are in places with very dark skies, you've probably noticed dots moving across the sky that aren't planes and aren't meteors. They're things that humans put up there. We're going to see a lot more of these. And some of the people impacted by that are astronomers, again, that have these big telescopes that are big light buckets. They're trying to collect as much light as they can from things that are very, very far away. And if you see all these kind of dots that are reflecting light into that light bucket that they don't want, that could be an issue. And so, yeah, we have developed this app that can kind of predict what that light pollution might be for any observer. But I will say that SpaceX has been working with the astronomy community to try to find ways to minimize that light pollution in terms of making their satellites a little bit darker or less reflective, or orienting their satellites in such a way that it minimizes how many photons get reflected towards the Earth. So they're being proactive with trying to find some sort of compromise with the astronomy community.
And I want to keep reminding everybody, I can see that there are a lot of you out there watching. Be sure to put your questions in the comment section. We'll get to as many of them as we can. We have friends in New Hampshire, Colorado, India, Louisville, Kentucky, Missouri, Santa Fe, Herndon, Virginia, and South Carolina are all watching. Let's see, how do rockets or shuttles get through the debris without running into anything? And will there be a time where they can't get through?
So I have some good news and some bad news. The good news is that as we collaborate across the globe to develop an improved space traffic monitoring system, like with Astro Graph, for instance, and to the degree that people want to be proactive and provide information so that we can plan and all this stuff, I mean, the answer is we need to find ways to make space more transparent, make space more predictable, and then develop a body of evidence by which we can hold people accountable for their behaviors, because not everybody is a great steward of the environment, and we need to bring that to the public square. That said, the bad news, aside from some people just not being compliant with these sorts of guidelines that people have put out there on what sustainable behavior might be, is that these things are already running into stuff. Like I said, there are these random things we can't predict where they're going to be because we can't track these things. They're too small to track that sort of stuff. The collisions are happening already. We just hope that a very detrimental collision doesn't happen. But these collisions are for sure happening as we're launching stuff and putting stuff into orbit, for sure.
A lot of people are asking if there's a plan to deal with the growing population of of these objects, can we clean them up? And how would you do that?
Yeah, so that's really excellent. So also some good news and bad news. With the good news, there are people all over the world looking at this. Let's start at a very high level. Let's say at the United Nations level, there is an Office of Outer Space Affairs in Vienna. And within the UN USA in Vienna, there's a committee on peaceful uses of outer space. They have met over several years, and last year, by consensus, over 90 countries signed on to this 21 guidelines towards long-term sustainability of the space environment. So that's great. Now the question is, okay, so we signed up to this stuff. How do we implement this? Because the thing is, these guidelines are not legally binding in and of themselves. So now it's up to each country to adopt these things and actually implement it and make good, right? Enforce these things maybe. Now here's the tricky aspect of it. How will these things be interpreted? There's a cultural lens that we need to evaluate this stuff through, because the way the Americans interpret this stuff may be very different than how Arabs interpret it, may be very different than how people in India interpret it, because the way we interpret things is by and large dictated by the customs that we grew up with, our perspectives on things. And so that cultural aspect, I think, still hasn't been addressed. And the other thing too, which I started saying at the beginning, is if you want to understand something, you have to be able to predict it. And if you want to know something, you have to measure it. How can you enforce something that you don't know? So in order to enforce a law, you have to know that somebody broke it and is non-compliant. And to know that, it has to be measurable. And we still don't have a global pool of measurements that's like persistent eyes on the skies. We don't have that yet. And so that's what we need to be able to achieve.
Someone asked, can the Astro Graph system predict re-entries of object into orbits? I guess can it predict when they are out of orbit and burning up in the atmosphere?
So interestingly enough, with the help of a colleague of mine at University of Arizona, his name's Vishnu Reddy, he alerted me to this using like NOAA radar. So NOAA, Doppler radar across the United States. Interestingly enough, this NOAA radar doesn't just track cloud cells, it can actually detect things that re-enter the Earth's atmosphere. And so with my students, I've actually been looking at NOAA radar data to try to see when these things might re-enter. And so we're in the process of trying to get the NOAA radar data on things that re-enter, coupled with the orbital information that we have in Astro Graph, to try to join these things. So we're in process. Astro Graph right now, it doesn't do that, but we're going in that direction.
Someone would like to know, do astronauts ever get hit with debris when they're doing a spacewalk?
So like I said, I mean, I know quite a few astronauts that are good friends of mine. I have not spoken to any of them that say that they've had perforations in their flight suits or spacesuits as a result, but they do hear these things dinging against the hull of different parts of the space station, and the station does have to maneuver out of the way. So it's definitely a risk. It's a risk. It's not zero. And we hope that we just don't have one of these very high velocity impacts with an astronaut during one of these spacewalks. So
that would not be good. Not at all.
Not at all.
Which orbit will be saturated first? And can you talk a little bit about the different orbits? Because some of these satellites are up higher, some of them are closer into the Earth. So could you talk about what those orbits are, where we might be saturated first?
Yeah, so it's a great question. So just like we have certain shipping lanes in the oceans, we have these kind of orbital highways. And one of them goes from about a couple hundred kilometers altitude all the way up to about 1,200 kilometer altitude. And we tend to call that low Earth orbit. And satellites that do Earth observation and these sorts of things, typically that's where we put things. There's a specialized type of orbit called sun synchronous, which is one of these orbits where you put the satellite in that orbit, and because everything's not perfect, different types of forces are tugging on the orbit and make the orbit kind of precess or rotate. But there's a special orbit where that precession happens at about a degree per day. So it keeps the same profile with respect to the sun. So you get the same shadowing effects, kind of consistent revisiting and that sort of stuff. So, and unfortunately, that orbital altitude is also where China destroyed one of its own satellites back in 2007. So there's a lot of debris that was intentionally created during that. So I would say that sun synchronous orbit around 800 kilometers, and actually we have an app that can show you, what that kind of saturation is per orbit regime. That's leveraging Astro Graph. But yeah, right around the 800-kilometer orbital altitude is where we have a lot of stuff, a lot of garbage. But then it's like we have a place where we have global navigation satellite systems like Global Positioning System, GLONASS, and that sort of stuff, which is roughly about 20,000-ish kilometers above the surface. And then we have where we put direct TV satellites and all these sorts of things. That's called the geostationary or geosynchronous region, and that's about 36,000 kilometers above the Earth's surface.
And these satellites, can you tell us how important are they to our daily lives?
Yeah, and that's where, because people, they definitely want to know that, right? It's like, well, if we lost these things, what's the impact? So I'll put it this way: more and more of the daily technology that we use has some sort of connective tissue with hardware in space. So everything, again, from position navigation and timing with global navigation satellite systems. And oh, by the way, not just knowing location, but even financial transactions are now time-stamped with the timing from these satellites. So if those satellites disappeared, that you haven't even seen what riots look like, right? If you go to your bank and can't get cash, that's a bad day for a lot of people. Weather satellites that can predict when people might need to relocate and these sorts of things for disaster relief and that sort of stuff. That is also a significant capability. Agriculture, where should we plant certain things? Because now I have sensors that can see through the soil and can tell what are the more optimal places for me to plant certain crops for yield and these sorts of things, because we do have a supply and demand issue with resources on the planet with a growing population, right? Communications, not just satellite TV, but just regular routing of communications as well is now, space-based, and even the internet itself is moving to becoming, uniquely a space-based capability. So more and more of the technology that we depend on is becoming space-based, and there is no space vice, space cop to protect any of these resources from suffering damage from any of these collisions or anything like that.
I don't know how I would find my way around any town that I haven't been in without my cell phone and the maps that I can get to tell me where to go. I used to use paper maps, but I haven't in years and years.
I can tell you this, Beth, right? It's like when I used to use paper maps, especially going to cities, it would be so frustrating because you'd have to stop every couple of blocks to ask people because just the map couldn't really be that useful. So yeah, it was very challenging.
Yeah, the satellites now have really helped with that. Is there any way to see this debris from the ground?
Yeah, so that's exactly how we develop these tracks and that sort of stuff. So I said the most prolific giver of knowledge about where stuff is comes from the U.S. Department of Defense. The 18th Space Control Squadron, those folks, they're the ones that assemble all these observations from radars and telescopes. And from these radars and telescopes, the radars are usually for things closer to the planet, and they work through all weather. The telescopes mostly things that they can see further out and mostly useful at nighttime. But from these disparate sensors that the US government has that are part of the Space Surveillance Network, the 18th Space Control Squadron puts all this stuff together with math and physics and comes up with some estimate of where these things are located. And then they provide it through this, spacetrack.org. And in fact, my own research group, I have two telescopes that I operate remotely. One's in Australia with this guy called Lachlan Thompson. He's a reverend that wanted to collaborate with me. So one of my telescopes is with him at the Emerald Observatory. And then I have another telescope that I share with the Russians at this telescope farm called New Mexico Skies. And both of them are operated from here, from Austin, and a third telescope going to India. So yeah, telescopes and radars is the way that we track and see the debris, but we don't actually see it as a resolved object. We only get a dot of light, a dot of energy that comes back. And so the challenge is we have an identity crisis of stuff in space. These objects don't report their identity because they're dead. So the thing is, through math and physics, we have to sort out what all these darts are and come up with like a first and last name for these things. So it's a very challenging problem.
Now, if you are outside at night, we do have a video that will show you how to spot the International Space Station. So be sure to check that out because that is a lot of fun to look for in the night sky. Can it be argued that the new idea of microsatellites or CubeSats are effectively creating more junk?
So a coin has two sides, right? It's heads or tails. Tomato. So it depends on the perspective that you want to have. I think that CubeSats can be very useful. Case in point, you have this company I spoke about, Planet. They have these 3U CubeSats. So it's like a CubeSat, 1U CubeSat is just 10 centimeters by 10 centimeters by 10 centimeters. So 3U is like 33 of these kind of put together. And it's the first company that just said, listen, we're going to go on the cheap end and put these things up there, and we're going to image the entire planet once every 24 hours. That was positively disruptive in very, very great ways for the community writ large and the data that it's producing and the things that we can find out with it. So I think CubeSats can be very useful. Are all CubeSats useful? No. So it depends on how you do it. I mean, some people want to put up a CubeSat without any regard of the thing actually working. They just want the thing to be spit out to say, oh, yep, victory. Maybe that's not so useful, but things like other folks have definitely gotten some great science and great benefit, I think, to society as a result of CubeSats.
Your cousins in Philadelphia are watching. The Highsmith family is watching, and they say that you're killing it. Just so you know. So you've got some fans out there watching. Does all of the space junk orbit Earth, or does it get even further out?
So that's an excellent question, and certainly one that gets astrodynamicists really riled up. So just quickly, hi to the fam in Philadelphia and to the Highsmith family. I worked with them at NASA's Jet Propulsion Lab, so very near and dear to my heart. Here's what we believe, right? So there's some people that study astrodynamics in terms of what's called dynamical systems theory, and they look at this, what we call the n-body problem. What are the different warpings of space-time, given Jupiter, all, the moon, the sun, like all these things. And there's some places of stability and some places of instability, and there are natural cleansing mechanisms for some of this debris for sure. Like, Professor Kathy Howell at Purdue, Dan Shears at University of Colorado, this is kind of their bread and butter. Aaron Rosengren at Arizona. So they've been looking at some of this stuff. And interestingly enough, over maybe 100 years, 200 years, depending on where some of this stuff up is located, natural tendencies in the deformation of space-time could actually cleanse some of these things. But we're talking about waiting 100 plus years. We don't tend to be that patient, because human lifespans, they're getting longer, but the century thing isn't, we all don't reach that. So we're talking about several human lifetimes in order to cleanse some of these things. But it should be part of the solution. And so when it comes to solutions, I'm less of a Lord of the Rings, one ring to rule them all kind of guy, and more of a hybrid thing where we shouldn't be or people, we should be and people. And so we can go physically grab debris. So there's a company called Astro Scale in Japan that's looking at being the sweepers of space, right? There's Clear Space out of Europe that just got funded. They're gonna go up to this thing called the Vespa payload adapter in 2025 and remove it to show that they can clean debris. So that's got to be part of the answer, right? Survey satellites actually demonstrated on orbit a net and a harpoon. I guess fishing satellites, right? Nets and harpoons. They showed this like for real on orbit. You can see it on YouTube. So there's some of that, but we have to be and do that. And what are these natural places where if we just nudge something over the next couple of centuries, Mother Nature will take care of kind of like cleansing and removing it. So we should look at that.
Someone has said that they spend a lot of time outdoors, and how can they tell the difference between a shooting star and space debris falling and burning up?
Yeah, so I would say it's all in relative velocity. So for sure, when you see a shooting star or a meteor that is like re-entering, that's going to be coming very, very fast. We're talking, tens of kilometers per second, and it's just going to be traversing the sky kind of very quickly. It's going to be more of a transient kind of thing, right? Where if it's something that is human-made and entering, it's going to be burning up a lot more slowly. You're going to be able to see it for a lot longer time span. And so it's all kind of the relative velocity. And it makes sense because these things, I mean, they're entering at 7 or so kilometers per second is kind of the orbital speed that they're coming in at, right? Versus tens of kilometers per second, something that is outside of probably the Earth-Moon system and just kind of gets pulled in by Earth's gravitational field and burns up in the atmosphere. So it's all about that relative velocity to kind of tell the difference.
And I want to wrap up today by asking you, how did you get interested in looking at the night sky?
Great question. So I enlisted in the Air Force after high school, and my job as an enlisted person in the Air Force was a security policeman. I was a cop stationed at Malmstrom Air Force Base in Montana. When they told me I was going to go to Montana, I had to look it up on a map because I had no idea where Montana was. Great Falls, Montana. And I heard that there's some people in Montana on here, so hooray to you folks in Montana. And so they called Montana Big Sky Country, and that's definitely true. And I grew up in Caracas, Venezuela. I mean, millions of people, lots of light pollution. On a good night, you might be able to see the moon. And so by going out to Montana and pulling night shifts, guarding nuclear missiles of all things, I would see these dots go across the sky. And they weren't planes, they weren't meteors, right? The whole thing and it would just go across the sky kind of quick, but not that quick that you couldn't see it. And I wondered, what were these things? And when I did a little bit of homework, I come to find out that it's stuff that humans put up there. And so I think that really crystallized my curiosity to try to find out more about what is this thing that we call orbits and that sort of stuff.
Moriba, thank you so much for joining us today. This has been a great talk. I want to remind everybody that next week we will be talking about Mars in advance of the 2020 rover launch. And the following week, we will be talking about the Chandra X-ray telescope with astronaut Eileen Collins. And just to remind everybody, the National Air and Space Museum wants to invite you to launch a conversation with your friends and family about previous space launches and what was going on during those times. Thank you all for watching today, and thank you for joining us.
Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX.
The National Air and Space Museum is launching a conversation.
We want you to be a part of it. The history of exploration can't be viewed without looking at social, political, and historical events that were happening at the same time.
These are all part of our story.
These are all part of our story.
Part of your story.
We have created resources for you to launch a conversation
with your kids,
with your parents, with your family.
To look at the past,
to learn about today. Join us.
Join us.
Join us
to launch a conversation.